Right, here's a centre of mass question from Mei M2 January 2011, question 4. That's part of it, that's the initial description. Pause the video if you like and read that more carefully, and then go on to the next bit, which is here. Again, pause if you need to. Okay, let's get on. It's a centre of mass question. First of all, they want us to write down the centre of mass of the triangle OAB. Now, I've already done this part of the question because there's not much to it, and you can verify the different parts easily yourself. First of all, for the triangle, they tell us that the centre of mass of a triangle is 1/3 of the way up the median, any median. So, for just one mark, 1/3 of the distance, well, it's 6. The median is of length 6, so this distance here is 2. And the coordinates of the centre of mass of the triangular bit is x is 2, y is 2.5. I've said that y is 2.5 by symmetry. I know it's obvious, but we know that the centre of mass is on this line. Now, to find the centre of mass of the whole thing, we need to make up a table the usual way of masses and distances. In this case, we'll measure distances from the y-axis. It used to be consistent with the first part, which asks for coordinates. So take a moment to pause the video and check the masses and the distances that I've got in this table. Masses and distances. Once you've done that, it's a simple matter, a little bit of tidying up needed. Take moments about the y-axis and tidy it up to get x bar. So again, something you can pause and try yourselves. So we get that expression for x bar, and let's go on from that. The next part of the question talks about the prism being placed on a horizontal plane. At the moment we don't have this F force, sorry, that was me getting ahead of myself. And for part 3 here, find the value of h for which the prism would topple. Now, h affects x bar, obviously. We've got this expression for x bar. It'll topple, the whole thing will topple, if the centre of mass of the whole thing is to the right of this vertical line, in other words, to the right of the y-axis. In other words, if g is over here, because then the weight will act outside the base and tip it over. So all we have to say is that x for toppling, it topples if x bar is greater than 0, if it's positive. The bottom is clearly positive, twice 3 plus h, so we want 12 minus h squared to be positive. So h squared is less than 12, h less than square root of 12. We're going to ignore negative because we're assuming h can't be negative because it's a dimension. That's that part done, and just in the right here I'll do this last bit here. The following questions refer to the case when h is 3. Well, that tells us x bar. Let's quickly work out x bar. X bar works out to be 12 minus 9 over 12, which is 0.25. Right, and now they say, suppose the prism is held in this position by a vertical force applied at A. Okay, well, the vertical force applied at A would look like that then. Let's just call it F. And you can see what's got to happen. F has got to counterbalance the turning effect of the mass at G, of the weight of the prism. So let's take moments about O. I'll stay in black so it doesn't look mixed up with the rest of it. Moments about O, then F times 6 has to equal the weight of it, 15. Oh, I didn't point that out, sorry, they said that in the question. The weight of the prism is 15, sorry, I should have read that out first of all. So F times 6 is the weight of 15, which I should have shown here, I suppose, yep, times 0.25. Right, and that finds us F. So F works out to be 5/8, 0.625. Okay, that's that bit. And there's one more bit to this question which we'll just get to. This time, for part 5, they want a force applied here at the point C, as shown. We've still got the weight of the prism at 15 at 0.25, and we want to find the magnitude of the force if it's on the point of tipping anti-clockwise, in other words, tipping that way. So it must be going to tip about this point D here. Right, moments about D then. On the point of tipping, the reaction force from the base of the prism would be acting through the point D. So moments about D doesn't bring in the reaction force, luckily. And we've got P. The clever thing to do here is to split P up into components. P cos 30 times 5 has a moment about D, but P sine 30 goes straight through D. So no moment. So P cos 30 times 5 is equal to 15 times a total distance of 3.25. And that gives P equals 11.3. Again, I won't show all the steps. It's a simple matter of putting them in your calculator, putting the numbers in your calculator. P equals 11.3. Right. Let's quickly have a look at where the marks were for this question. We've got to go back quite a long way. Right, this is the first bit. For this part then, there was 1 mark for getting those coordinates. Right. And there was a method mark for the table, without spending ages putting them in all the different places, there was 1 method mark and 4 accuracy marks for this part of the question, making a total of 6 marks for these first 2 parts. Okay, the method mark was for the moments, and the accuracy marks were for putting the right numbers in the table of masses and distances, and obviously getting the correct expression at the end. Going on. I think I missed one question out. There was one more mark. Let's go back. There was a mark for saying that the y was 2.5. Yeah, there was a mark there. Yeah, that's right now. And then going on. Right, for the toppling and the h squared less than 12, a method mark for saying that x bar is greater than 0 for it to topple, and then 2 accuracy marks for the 1 accuracy mark for ignoring a negative, it would appear, and just using the positive square root. Okay, for finding the value of the force F, there was a B mark for writing down the value of x bar, and then a method and accuracy mark for taking moments and getting the right value of F there. And then right at the end, 4 marks for this. So there was a method, there was a B mark for using P cos 30 in the taking moments, if I'm reading the marks correctly. And then there was a M1 and an A2. That gives 4, doesn't it? Yep. Okay. One of those accuracy marks was for the 3.25. Yeah. The other one was for getting the final correct answer. Okay, I hope that was useful. Thank you for listening. That's the end of that question.